are good. They should be good. They are good. Let's rock and roll. Okay, so we're going to make our lives a little bit easier here, and we're going to take a very logical approach to something that's scary and very important. And hopefully by taking a logical approach to it, it won't be so scary. We're going to build on what we've already done. Okay, so clicker not working, board not working. All right. Increasing and decreasing functions and the first derivative test. The first derivative test is something you're going to do so much, you're not going to be able to handle it anymore. It will drive you partially insane. And then, after you're completely insane from the first derivative test, we'll then throw the second derivative test in. That comes later. So, we're going to determine where interval is increasing and decreasing, not difficult. We're going to talk about the first derivative test. So what we've done so far, just to make sure that you remember where we're at, we should be able to look at a function and determine where the critical numbers are. And we talked about the fact that some of those critical numbers could possibly be extrema, minima or maxima. And then we talked about all the 4 different types. We're going to focus mainly on relative max and relative min. So now what we need is a process to figure out, well, okay, I got a critical number. It could be a max or a min. Which one is it? And that's what the first derivative test will do. And then today, if you haven't already done so, you should compliment 2 strangers. Excuse me 1 second. I have to admit somebody to class. What do you want to guess? No, it's not Noah. It's Federico. Federico, where are you?
Sorry, I wouldn't let me connect.
See, Wi-Fi issues. Knew it. Winner, winner, chicken dinner. Wasn't even a challenge. Okay, so let's go back to the hill. The entire lesson can be explained with this picture. Okay? So here we go. This is where you start. And then you go up the hill. And we hit the peak of the hill. And then, let's change colors. And you come down the hill. This is not Rolle's theorem. This is not mean value theorem. This is a simple explanation about the first derivative test. So, when I hit the bottom of the hill in red and I start going up, is it not obvious that that's where it is increasing? Because it's going up. Then I hit the top of the hill. What can someone tell me about the top of the hill?
The derivative, like at the tangent is 0.
Good. Which is the same thing that Mitch just said. Yeah. The tangent line has a slope of 0, which means that that is also a critical number. From a mathematical standpoint, we could have easily found that it's a critical number. What we might not have known is whether it's a maximum or a minimum. But notice in this case, we know that's a maximum because it's the top of the hill. So to get to that top, we increased, got to the top of the hill, and then decreased in blue. What if it was a pit or a valley? Well, I would decrease first, and then increase. Anything difficult about that? Does it make logical sense? Yes. If you remember this picture, the rest of the slideshow should be pretty straightforward, hopefully. Let's give it a whirl. Ooh. It's a blue rectangle and a bunch of gunk. However, this is worth talking about. And I'm going to read it to you, even though I know you can handle most of the big words here. A function is increasing on an interval if for any 2 numbers, x1 and x2 in the interval, x1 is less than x2, and that implies that the f of x1 is less than f of x2. In other words, if x is to the left, if x1 is to the left of x2, then the y value for x1 has to be lower than the y value of x2. The opposite is true for decreasing. This makes no sense whatsoever. However, That might make more sense. If it's going up, it's increasing. If it's going down, it's decreasing. What if it's doing neither? Then that would be a constant. If, for instance, you were climbing up the, I think it's called the Devil's Tower from Close Encounters of the Third Kind. Am I dating myself? Have any of you ever seen that movie? Oh, boy. No? Okay, never mind. Are you familiar with the Devil's Tower in... No? Okay, never mind. Bad analogy, really. Let's move on. Maybe I should have included a picture of the Devil's Tower. Who cares? I could draw, yes. The Devil's Tower looks like this. It's a land structure that looks like that. It's actually flat on top. So it would be increasing until you get to the top, then constant across the top, then decreasing coming down. In the movie Close Encounters of the Third Kind, Richard Dreyfuss, the star of the movie, has an alien interaction. He starts to have flashbacks and visions of the Devil's Tower. So he travels across country where all of a sudden the aliens show up, and it's Steven Spielberg. It's a good movie. Watch it if you haven't seen it. Okay. Now, there's a fancy way that we can talk about this. If we go back to the hill, and let's clean this up a little bit. Let's get this. We won't worry about the valley. We'll just worry about the hill. What can you tell me? Actually, I'm going to put this one back in. This one we already had. At the peak, the slope is equal to 0. Or, because we're calculus, f prime of x equals 0. What can you tell me about f prime in red?
Positive.
It's always positive. Greater than 0. Over here in the blue, f prime of x. I don't know if that's... Can you guys see that?
Kind of.
Yeah, kind of. Okay, I'll change to black. F prime of x is less than 0, also known as negative. Does that make sense? Good, 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 good. And then number 3 is the constant. Like the top of the Devil's Tower. Oops. All right, we good? Again, if this doesn't make any sense to you, don't write it down. Or write it down in such a way that you understand it. If the derivative, like, simple example, if f prime of x is greater than 0, if that doesn't mean anything to you, you might want to write the derivative is positive. If the derivative is positive, it's increasing. If the derivative is negative, it's decreasing. If the derivative is 0, then it's a constant. Okay, first example. Hopefully this won't be too bad. Find the open interval in which x cubed minus 3/2 x squared is increasing or decreasing. Okay, so before we get started, pull out your handy-dandy calculators or your crazy little iPad using Desmos and graph that bad boy so you have an idea of what we're looking at. And in fact, if you look at the graph, you can probably answer the question already, but I don't care about it. I would just like you to see what it looks like before we start diving into it. All right, Ryan, tell me what we're looking at here. Cubic?
Yep.
Looking at your graph, does it appear to have any maxima? Are there any hills?
Yes.
Okay. Does it appear to have any minima, also
Yes.
known as valleys? Yes. Okay. Does it appear to be part of that graph is increasing?
Yes.
Okay, good. Does part of it appear to be decreasing?
Yes.
Excellent. Can we find all of those?
Yes.
Yes, that's why I chose this as an example. Okay, so like I said, you could just look at the graph and ballpark it, but we want to do the numbers. First things first, I want to find the critical numbers. Remember, Critical numbers might be maxes and mins, but all maxes and mins must be critical numbers. Okay, dogs and golden retrievers, you'll recall that. So go ahead, find the critical numbers, please. And I'm sure you remember that. Take the derivative, set it equal to 0, solve. Oh, geez. That's not a good text. My daughter was just in a car accident. She's okay, in case you're wondering.
Yeah.
We're good.
Jeez. It's not a good text.
Hmm?
It's not a good text.
It's not a good text. I shouldn't even have looked at my phone.
So was it like a side, head on?
No, rear end. She was stopped at a light and a girl was doing about 40, fixing her radio, wasn't looking, and slammed into the back of her.
Oh my gosh.
That girl should be shot. Am I recording this? All right, I'll have to cut that out later. Probably don't want to go on record as suggesting that someone shoot another person. Okay. Let's see. Who can we pick on today? Gabe, let's go with you, buddy. What do you got for critical numbers?
I got 0 and 1/3.
Can we get a confirmation from the crowd? 0 and 1/3 is critical numbers.
Yeah, 0 and 1. 0 and 1.
The rest of the crew seems to have 1, Gabe. Well, let's take a look. Obviously, either they're all wrong or you made a mistake. I don't remember. We'll see. It's okay to be wrong, though. We still love you. Okay. Oh, wait. I didn't do it. F prime of x is equal to 3x squared minus 3x. Right? Because 2 comes down, cancel with that, 3x. Yep. Okay, which means, set that equal to 0. 0 is equal to 3x times the quantity x minus uno. That's Spanish for 1. Therefore, the critical numbers would happen when x equals 0 and x equals 1. I'm sorry, Gabe, I tried to have your back, buddy, but it does appear that it's 1. Okay, now, of those critical numbers, we cheated and we looked at the picture. But if we didn't look at the picture, we then have to figure out what's going on with 0 and 1. 0 and 1 could be a max, could be a min, could be neither. You'll see that more as we start getting more in depth into that. How are we going to figure that out? Well, we're going to use increasing and decreasing, excuse me, and something called the first derivative number line. So we're going to take a number line. We're going to label it f prime. This little f prime at the end is very important because later on we're going to have some other number lines and you need to distinguish that as an f prime number line. Okay? Step 2, put your critical numbers on there. 0 and 1. And then test some regions. Now, what does it mean to test regions? There's a reason why that's there. Number 1, it identifies it as a first derivative number line, but it also tells you where we're going to test values. I would like to know, in the region from negative infinity to 0, is the derivative positive or negative? From 0 to 1, is the derivative positive or negative? And from 1 to infinity, is the derivative positive or negative? Okay, so I had the derivative being f prime of x, from memory, 3x times x minus 1. Did I do that right? Yeah, okay. So I pick a number to the left of 0. I don't know, let's say negative 1,000. If I put a negative 1,000 in there, I don't care about the value, I just care about the sign. If I put negative 1,000 in there, this would be negative. This would be negative. A negative times a negative is positive. Moving to the right. I need a number between 0 and 1. Oh, I don't know, 1/2. Okay, so I plug 1/2 in there. Let's see, if I put 1/2 in there, this is going to be positive. Whoops. This is going to be negative. A negative times a positive is negative. And then I put a number over here in the right, a big honking number, let's say a gabillion. If I put a gabillion in, I get positive times a positive, which is positive. Now, what do those values mean? If you've been paying attention, we now know that the graph is increasing. Show that with a little arrow there. Decreasing in that interval and increasing in that interval. Make sense? Yes? Okay, good. You're going to do that a lot. Oh, here, let me get rid of this mess. I forgot I did all the work. It looks a little cleaner than my childish handwriting. Okay. Test the regions. If it's positive, it's increasing. If it's negative, it's decreasing. You'll also see that these arrows kind of show you a general shape of the curve. I'm assuming that the cubic that you got when you looked at it looks something like that, right? It went from negative up to positive. There you go. And you can see that it also comes into play over there, something like that. Okay, let's talk about this. What appears to be true about 0? It's a relative maximum. Okay, we've hit the top of the hill. We went increasing and then we stopped and went down to decreasing. I know you're all good at pattern recognition, so what happens? What do you think is true about 1? It's a minimum, correct. We're just about done. We've done all the hard work. All those concepts go together, and that business that we just talked about on this number line is what the first derivative test says. The first derivative test uses the first derivative to test whether critical numbers are maxima or minima. Okay, so I missed on Close Encounters of the Third Kind. Do you guys know Austin Powers at least? Okay, good. 'Cause every time I say maxima, I keep thinking of liquid hot magma. No. I gotta pick some newer movies, right? Okay. I'll try to update my movie information. Rehashing what we just did. There's our graph. We took the derivative. We set it equal to 0. We found the critical numbers, 0 and 1. The picture matches what we knew. It was increasing, then decreasing, then increasing. And also now we know that, based on what we just talked about, that at 0, we have a relative maxima. And at 1, we have a relative minima. Okay, so this is the first derivative test. So let's break this down from a calculus speak, and that is, we find critical numbers. One thing that people always forget about is this little chunk of information. Not only do we get critical numbers where the derivative equals 0, but we also get it where the where the derivative is undefined. Things like vertical asymptotes and that kind of fun stuff. If f prime changes from positive to negative, okay, positive means going up, then going down, we have a maximum. It's the top of the hill. Step II, if it goes from negative, decreasing, to increasing, we have a minimum, going down into a valley. If it never changes, then there is no max or min. Like, for instance, a line. Okay, that line would have no maxima nor minima because it's always increasing. Does all of this make sense? Okay, good. If you understand the concept, then when you get into the ugly problems where you're really having to grind out some derivatives, this shouldn't bog you down. Okay, here we go. Another cubic. This time we're not going to graph it. We're just going to attack it. We want to find the relative extrema. Meaning, I want to know where the maxima and the minima are. Or if there aren't any. Maybe it just has a max. Maybe it just has a min. Maybe it has 47 maxes and no mins. That probably wouldn't happen, but... Okay. So the process, if we take everything we've done prior in the slideshow, it all comes together in one nice little neat process. Take the derivative. Set that derivative equal to 0. This is where you pick up your handy-dandy calculator and your quadratic program that you have, and you plug in this into the quadratic formula and tell me where exactly the critical numbers are. That probably factors, but I'm too lazy to do it because it's Friday afternoon and who cares?
So 3x plus 5 factor, x minus 1.
It does factor?
Yeah.
Good. So just cut to the chase and tell me what the critical numbers are.
Negative 5/3 and 1.
So Mitch tells me negative 5/3 and 1. Can somebody confirm that? Beautiful. Okay, good. One of those might be a max. One of those might be a min. They both might be maxes. They both might be mins. Who knows? How do we figure it out? First derivative number line. Okay, you're going to laugh at this until it happens to you. But remember when I said people always forget about this? The second most common thing that happens, again, you're not going to believe me, is people don't know how to put numbers on a number line. If you put them in the wrong order, it screws everything up. This is a negative number, so it should go over here to the left of a positive number. Okay. You know what, Mitch? I'll take that factored form, please. 3x
Plus 5.
plus 5
X minus 1.
and x plus 1. X minus 1, right? Yep. All right. Now, the reason I wanted the factored form is because it's going to be easier when we're testing regions. So I'm going to pick a number way over here on the left. Let's say negative 10. If I put negative 10 into this function, and remember, this indicates where we plug into, the derivative, not the original function. If I put negative 10 in here, I get a negative number times a negative number, which is positive. That part of the function is increasing. Oh, I don't know. What's a good number to pick in here? 0. Positive times a negative is negative. Decreasing. Oh, it's looking very cubic so far. And a big honking number like a gabillion. A positive times a positive is positive. Bingo. Hard part is done. What do I now know? I know where the function is increasing and decreasing. I know where the maxes and mins are. I know where the critical numbers are. I know all kinds of fun stuff. Next slide, you're not going to like. So the College Board, i.e. the people that are going to give you your AP test, are very persnickety. They like you to write in a math classroom. And one of the things they like you to write is this sentence. So once I found, I'm going to jump around here for a second. Once I found this, I think we all agree that at negative 5/3, I have a maximum. At 1, I have a minimum. Okay? Changes from increasing to decreasing, changes from decreasing to increasing. However, the College Board wants you to write a sentence saying that, and those sentences should look just like that. A relative max occurs at x equals 1 because f prime changes from negative to positive. A relative max occurs at x equals negative 5/3 because f prime changes from positive to negative. This is your justification for it being maximum or minimum. How are we doing so far? No problems? Everybody caught up? Can I move on? Good. Okay, this one you do on your own. I'm going to give you a couple minutes to play with this for a while. If you want to get up and stretch your legs, we will. It's 22, so 8 minutes. At 1:30, we'll come back together and talk about this. I'll have somebody volunteer to talk us through this. Okay, thank you. Carry on. I hate to be rude, guys. I gotta go. I gotta answer the phone real quick, okay? Sorry. Emergency situation. Sure. So what you should do is. Okay.
Is this like a product rule right here? Well, not product rule, but like the thing times the thing plus thing times the thing.
That's not.
Yeah.
Did she rear-end you? Oh, she'll get in trouble. She's automatically at fault.
What do you get for the derivative?
Well, and that is kind of a valid argument that you could have just locked up your brakes and caused it, which is fine. Purge. I understand. I understand.
Well, I would for rifle and jig screw. Yeah, like the lease is good. Yeah. What? The lease, I think the lease right
You see it? Well, the key there is no visible damage. For all you know, she could have made the front of the car display.
Incentive for sure.
Yeah.
Grease blades. I don't know if I know what else. What you can feel in the derivative?
Okay, so you have
What did you get for the derivative?
I'm definitely not 4x because it's 9.5.
I don't actually know that.
Like the hardest part of everything else is.
I'll try to find some time to do that. If nothing else, I'll do it after school. The important thing is, like I've always said, it's just a compromise. Now, as far as you go, you start, if your neck starts to seize up, or you start to get nauseated, go right to the medicines.
That's the very good question.
Because it could mean a concussion, it could mean a lot of things. You're going to be sore as hell. And we'll go from there. Okay, I'll call bodybuilders and I'll call you back in a second. All right, bye.
Wow, that was fun.
Sure, right?
Yeah, she's fine. Just people being jerks.
Really?
Yeah. Hi, everybody. So, quick story. I think we're past the 8. Well, no, we're not past the 8 minutes yet. But I just happened to have my text sitting here, or my phone sitting here, and I happened to look at a text. My daughter was just in a car accident. She's fine, but again, you got to talk the 23-year-old off the ledge. So, anyways, let's talk
Is
about
your-
what's that?
Mary's Wi-Fi isn't working right now.
I know she just tried to get back in.
Okay.
Yeah. Hopefully she's back in. Mary, you back? Yeah, there she is. All right. Gavin, let's pick on you. Where are the critical numbers?
Would it be -4? Or no?
No.
I think I did it wrong.
Well, I don't know. Is it -4? I didn't take the derivative yet.
I don't know. I'm not gonna lie.
Oh, boy. Well, okay, so let's back up. Gavin, could you help me with the derivative, please?
Would it be 8 minus 4x over 3x to 2/3? I did it wrong though,
Yeah, you did it wrong. Okay. This is a product rule, yes?
Yeah.
Okay. So 1/3 x to the -2/3 times 8 minus x plus -1 times x to the 1/3. Whoops. To the 1/3. Be careful with your parentheses. Everybody good? You agree with me on that? Now, there's a reason why I chose this is because it gets back to the simplifying stuff that I've talked about in the past. This is a sum. I don't want a sum. I want a product. So I'm going to factor out what they have in common. And again, the rule is you take the more negative term out of there. That leaves me with 1/3 times 8 minus x plus, actually it'll be minus x. And remember, the reason that's x is because x to the 1/3 divided by x to the 2/3 is 1/3 minus -2/3, which is positive. X to the -2/3 times 8/3 minus 1/3 x minus x gives me x to the -2/3 times 8/3 minus 4/3 x. Okay. I succeeded in taking a sum and turning it into a product. And so, therefore, I'm out of board space here. I'm going to move over here. I have x to the -2/3 equals 0. And I have 8/3 minus 4/3 x equal to 0. And as ugly as that is, it turns out to be two nice answers. X is 0, and x is 2. And this is where things are going to get fun. The concept of the first derivative test should not be that bad. Hopefully, if I did my job well. It's this stuff that's going to get ugly. I'm about to erase the red. Are we good? Because I need more working room. Okay. I saw a couple thumbs up, so I'm moving forward. Okay, so f prime 0, 2. Ooh, I erased my derivative. I'm an idiot. F prime of x was x to the negative 2/3. Actually, you know what? I'm going to get all fancies into my pantsies here. And I'm going to do 1 over the cubic root of x squared. That might help some of you out. And 8/3 minus 4/3 x. Okay. That's where I'm going to plug and chug numbers into. If you're clever about this, you can save yourself a lot of hassles. Notice, for instance, this term will always be positive. Does everybody see why? Yes or no? Okay, good. A cubic root could be positive or negative, but because we're squaring it first, it makes it positive. So the cubic root of a positive will always be positive. Then the only thing we need to decide is this second part over here, this guy. Okay, so I put in a big negative number. Let's put in negative 10. Negative 10 is going to make that positive. It's increasing there. Oh, I don't know. A good number to put in there would be 1. If I put in 1, I get 8/3 minus 4/3, which is positive. Ooh, this is exciting. And if I put in a big honking number like 10, I get a negative because it's a positive times a negative. Well, that's weird. So let's start with the easy part. Bella, what can you tell me about x equals 2?
It's maxima.
Good. A relative max occurs at x equals 2 because f prime changes from positive to negative. That's what you were going to say, right?
Yeah.
Yeah, I knew
That's
that.
exact.
Okay, good. JT, what happens at 0?
Well, it technically it just stays increasing. Well, it's a critical number, but it doesn't. It just continues to increase afterwards.
Love it.
Yes.
Any idea what that would look like?
It would be like I don't know. Something like I could draw it. Give me a second.
Ooh, this is going to get cool.
I don't know if you can see this, but it's reversed on camera. But
Okay, like a kind of like a plateau looking thing. So
yeah,
if
that's what I'm thinking.
Something like this.
Yeah.
Huh. Increasing takes a break for a second and then continues increasing, flips over at the maximum that Bella told us about and goes down. Seems conceivable to me. I would actually just sum it up as saying something funky happens over here and I have no idea. Okay. That comes later where we'll do more calculus and we'll be able to determine that. Or if you just can't stand it anymore, you could slap it into Desmos, graph it and see what it looks like. But I'm guessing that JT was probably... JT, did you cheat? Did you graph this? Huh?
Oh, no, I didn't.
All right, fine. Just checking.
Yeah.
Okay, good. Now, I picked this example for 2 reasons. Number 1, because you needed to see the whole factoring stuff out again, but also because it gives me an example of where we don't hit a max or a minima. That is a critical number that is not a maximum or a minimum. It's neither. Okay. Questions? Yes, you will be expected to do that calculus. Yes, you will be expected to take a function like this, take the derivative and find the critical numbers. Time to come off the porch, kids. You know what that means, right? Run with the big dogs? Yes? Okay, I'll just keep clicking. You guys were with me, right? I love having people in the classroom. We're done.